Good evening, all. Today we are going to discuss about preparation of alcohol by the alkanes and alkenes. Okay, different methods are there. So let me discuss. First one, let me discuss. First one is on the alkane. On the alkane, see these alkanes are saturated, right? Saturated hydrocarbons. Alkanes are saturated hydrocarbons, hence they are less reactive. They are less reactive. It's very difficult to remove the hydrogen from these alkenes, especially primary and secondary alkanes. Okay, then what we can do here? Usually there is one method. So we'll take the methane and they will add the oxygen. Okay, so in copper tube, which is actually used by the industry at the 200 degrees Celsius and 100 atmosphere pressure. Okay, this is how methanol is prepared actually in the industry. Okay, so when come to the remaining alcohols, so first what they will do, suppose we have another primary alcohol, suppose we have a CH3, CH2 and CH3. This one first they will convert it into alkyl halide. Okay, suppose this is alkyl halide. So what they will do now, for this one CH3, CH2 and CH3, they will add chlorine. It will makes a substitution reaction under the UV light and all. Okay, to undergo substitution, free radical substitution. So it forms like just write like this CH3, CH2, and CH3. CH3, right? Let's see H like this. Okay, it undergoes free radical substitution here. Okay, so it will be and replace this hydrogen. It forms CH3, CH2, and CH2. This will be an Cl. Okay, now we got in the form of alkyl halide. Okay, so later what they will do actually, this alkyl halide they will take. So I think we got here CH3, CH2, one more CH2, Cl, and for this one they'll add a strong alkali like NaOH, strong alkali like NaOH. Then what happens here? It forms a CH3. The Cl group is replaced by the other OH. Okay, replace here actually CH3, CH2OH. This is how we prepare the primary alcohol. Okay, so this is the way they prepare the primary alcohol. Now, if it is secondary alcohol, mm, secondary alcohol. So think like we have CH3, CH, CH and CH3. We have CH3 here. This is I think the tertiary we got. So let me think that secondary alcohol. So anyhow, mm, think like we have. This is only this. Now if I take an bromine, so bromine. Okay, again this is free radical substitution here. Here it will be attack here. Okay, separate hydrogen will be separated here. See? Okay, so later it forms now. Forms CH3, CH, which is Br, and CH3S3, and we got now a secondary alkyl halide. Okay, now the secondary alkyl halide for this one, secondary alkyl halide. This is CH3, CH. This will be an Br, and this is CH3. For this one, they will add mild, okay, mild NaOH. They will add mild base, okay, so that it forms CH3, okay, single bond the CH, and you get a OH here. And now this will be an CH. Now see here we replace this alkyl group by the alcohol, okay. This is how we prepare the secondary alcohol. Here we got here, earlier we got here we got this is primary alcohol, okay na. Now come to the tertiary alcohol. So how we can prepare tertiary alcohol? So now think like we have tertiary alcohol. Suppose CH3 taken thrice C CH. Okay. Now for this one, this is easily replaceable because three alkyl groups are there. No? So that's why we will use oxidizing agent like KMnO4. What I'm saying here, the primary it is not possible to remove the hydrogen which is attached to the primary carbon. Okay, na? But whereas here we have many replaceable hydrogen because this is we have a tertiary hydrogen. This is electron donating group. This is electron donating group because of positive inductive effect. This will be carrying a partially negative charge and this will be carrying a positively positive charge. Easily we can break this bond by using the oxidizing agent like a KMnO4. So easily we'll get the CH3 taken thrice a COH. COH. Okay. Now we got here now tertiary alcohol. Okay. There is one more method, alternative method. There is one more method. Okay. Suppose after doing this one, suppose after having this alkyl halide CH3, CHBr plus CH3, whether you observed or not, this one if you're instead of mild base, if you're using strong KOH, alcohol KOH, it forms CH. Elimination reaction will take place. Elimination reaction here takes TH3 CH double bond CS2. Okay. For this one we can do hydration, direct hydration. CH2 single bond CH double bond CH2. Okay. Now what happens here? It will be shifted here so that it forms CH3 CH positive charge and later CH2 negative charge. For this one what happens? We are adding H plus ions and this H plus ions will attack here. Okay. Now it forms now it forms CH3. Okay. CH positive charge it forms CH3. Now we are adding the water, right? This water molecule attached directly attached to this carbon. So it forms CH3, CH, it forms OH2 and OH2 forms CH3. So later we can remove one H plus ion, whatever we added earlier. So it forms a CH3, okay, CH. Here you can see two hydrogens was there. So this electron shifted here and so positive. That is we are going to remove here. Here it forms CHOH gives plus CH, so single bond CH3. So now we got in this way we can get the this is secondary alcohol. Okay, now you can see here one thing you observed or not here. So when I'm taking, you can see here when I want to prepare primary alcohol. Okay, I took the chlorine. Okay, when I want to prepare primary alkyl halide alcohol, I took the chlorine because chlorine is actually less selective. Okay, it means that whenever you want to add the chlorine, it will be attached to the terminal alkyne groups, terminal alkyl groups. I mean, it's in terminal, it may be attack here or it may be attack here. When you specifically want to attack for the secondary carbon, in that time you should supposed to take bromine. So bromine is more selective. Bromine is more selective group. Okay, selective group. That's why we should take bromine. Okay, na? Now see in this case why we taken mild NaOH actually. If we taken strong, what is the result? Will be an gives rise to instead of substitution, it gives a elimination reaction. Elimination reaction. That's why I should take mild NaOH. Okay. So anyhow, so we learned how to prepare alcohol, how to prepare alcohol by the which one alkene. That we study how we can prepare by the alkenes. Okay, by the alkenes. So we have to write here by the alkenes from alkene. So alkene means En double bond will be there, CH3, single bond CH2, CH double bond CH2. So first one we are going to add concentrated sulfuric acid. Concentrated sulfuric acid here. So it forms now sulfuric acid split into H and HSO4. H and HSO4. This will be an what we can do is we separate here the thing. Then so it will be attacked nucleophile. It is forming a Markovnikov's rule. Very important. There is a Markovnikov's rule. So we are our nucleophile supposed to be attached to the more substituted carbon or which contain less number of hydrogen. So I can attach here this group CH3, okay, CH, and here we have, let me shift here for better first, okay, it becomes positive. This but we can attach here, so H SO4 group here and it will form CH3, okay. Now we got this one. Now for this one what we are doing, we are going to do hydration. H CHSO4, this will be having CH3. For this one, we are going to add hydration. Okay, so we are adding water. We are adding water. Okay, so HH. Now, what happens here? This will be shifted here. It will become negative. This will be shifted here. It will become positive charge. So we can attach here CH3, CH. We have positive or nucleophile will be attacked here. It forms CH2H, remaining is CH3, and this hydrogen will attach here. It forms, it gives H2 super whatever we had it earlier. Now this is where we got a secondary alcohol. Okay, now this is called indirect titration. Now let me do the direct titration. Direct titration. Okay, now direct titration, what we are doing? We are taking alkene. Take alkene here, CH3, single bond CH, double bond CH2. Okay, for this one we will add H plus. Okay, now what happens here? First let's push it here, so that it will get a positive charge, right? Now CH3, now we have CH, single bond CH2, negative charge, right? Negative charge at the second positive charge. Now this will be attached here. Now we will get here CH3. So we add H plus. It forms a CH3, CH, single bond CH3 and have a positive charge. Now for this one we'll add a water. Okay, we'll add water. It forms CH3, CH, we add O, H2 plus, OH2 plus, it forms CH3. Okay, now we added earlier H plus and now we are going to remove. Now what happens here? We shifted here, right? Like this, two hydrogens are there. Among that one will be this electron will be just a second. So we added water, right? We add water again. How we can add water in the sense? This is such a structure. So now we have add water. No? This hydrogen and this is hydrogen, and here one ground pair will be there. Okay, this is a carrying a positive charge. Now this will be shifted here. Okay, na? And now what happens here now? CH3, CH shifted here, and one H plus ion will be removed here. CH, OH used and H plus. We have one remove one H plus. Like right here, aroma remove proton. This is called deprotonation. Okay. This is how we are going to prepare again here. What we prepared here, we prepared again secondary alcohol. Okay. Now next, what we have? Next we have mm, next method we have borohydration, hydroboration method. Next we have hydroboration method. Next we have hydroboration. Now here we are what we are doing actually. Now actually here we are taking alkene. Please think like CH3 single bond CH double bond CH2. Okay. Now for this one we'll add B2H6. Okay, diborane will call. Now this one how it will attack in the sensor. This will be split into BH2 H. This is an positive, this will be an negative. Now how it will attack here? It will attack like this. CH3 CH. This is CH2. And here there will be an, what we can do. This is carrying what we can say. This is carrying here negative charge H plus. Hmm, this is H. This will be an, this is carrying positive charge now. Yes. This is BH2 like this. Okay. Now again for this one, if we are adding one more alkene, that is NRCH3, CH, CH2. So it gives rise to 2CH3, CH2, CH2, H. Again on addition of one more CH3, single bond CH, double bond CH2. What it is forming? It's forming CH3, okay, CH2, CH2, 3B. Okay. Now for this one, means this compound. Now we are adding. So we are adding H2O2. OH group we are attaching. Okay. And we are following anti-markovnikovsynhydration rule. Now what happens here? Get here CH3, CH2, and CH2. OH is attached here. H is attached here. Now we got finally what we got here, primary alcohol only. Primary alcohol. We are following anti-markovnikovsynhydration rule in presence of hydrogen peroxide. Okay. Plus we get something else like this. 3 H3 BO3. Okay. Boric acid. Now this is called which method? This is called hydroboration method. Hydroboration method. Suppose the same hydroboration method. Suppose we have this one. I think like we have this. We have a CH3, CH. We have CH3. think I have CH2. In this case also, okay, I'm going to go by not silicon. Okay, now how we can say? Think like here we have, okay, now here we have CH3. In this case also, if we taken H2B6, okay, due to H6 thermal. In this and H2 O2. In this case also forms like a CH3, CH. Again here we have CH3 and we have CH2, OH. Not in this position. Okay. So here also what we are getting? Here we are getting primary alcohol only. Okay. Next we have one more method. One more method called oxymercuration. Oxymercuration, demercuration. Here what we are doing? Here we are taking alkene CH3, CH3 double bond, CH3 CH3 alkene. This one what we are doing? We are adding CO. That's has to. It gives rise to CH CH3. Okay, CH3. Yes, yes. Here there is an OH should be added here. And here will be one H O C O. CH3. Presence of sodium. Okay. Hmm. Cannot it forms a rest. This one is added here. It forms a CH3, CH3, now CH3, CH3. It forms OH, it forms H. So we got here tertiary alcohol. No rearrangements. It's called anti-addition. Okay, this is how we prepared alcohol from the different method. Now let we discuss about some questions. Okay, now see here in this case. Hmm. Now in this case, you see the major product formed. Major product formed when 3-methyl butane is undergoes Sasser catalysis. 3-methyl butane. So there is 3-methyl but 1-ene they are saying. But 1, 2, 3, 4. Okay. But 1-ene. 1-ene means here 1. 3-methyl. Third place we have one CH3 group. Okay. Acid catalyzed reaction. First we should here. Okay. Forms CH3 CH, then CH3 group here. Here we have then CH shifted CH2 CH shifted here. It now forms a CH2 negative. There is an addition of H plus ions. It will be added to here, right? Now it will be an positive because of this is an secondary and this will be shift here. This methyl group will be shifted here. Forms a what result here? C There will be an OH here. There one more C will be there. Here one C, you have two C. To butane. So we can say 2 methyl, 2 ethanol. So 2 methyl butane. Second option is correct answer. Okay. So next we can see next they given propene on reacting with an B2H6. So you know very well just now we discussed it follows anti-markovnikovsynhydration rule in the presence of S2O2. So what we can say propene is a right here CH3 single double bond CH2. Okay. Now see here propene is a reaction with B2H6 means it forms whatever may be. So it attacks the OH here. So the result will be CH3, CH2, and CH2 and OH. How many? One, two, three. Three are there. Three means prop. Everything prop is there. Here we have alcohol in the one, two, three positions. One position, one hole. Propane, one hole. Something else we did wrong here. Okay. Propane, one hole. Propane, one hole. You see here. You see. Hydroboration oxidation reactions that result in the formation of addition of water across the double bond according to the anti-Markovnikov's rule and with zinc stereochemistry. Zinc stereochemistry remember. Okay, carbocation rearrangement take place. Zinc stereochemistry rearrangement. Remember these words. Now we have just now we discussed about this one. Now see and acid catalyzed hydration 1 methyl cyclopentane 1 methyl cis cyclo sorry this cyclo cyclopent 1 methyl they are saying 1 methyl cyclopentene they are saying in with double bond will be an CH3 okay. For this one what they are saying pentene correct measure product. So it will be an just now we discussed about mm, this is zinc right, this is zinc we discussed. Hydroboration zinc should be there. Hydroboration. Hydroboration third anti hydroboration. Anti-marker zinc is there. Zinc is there. Okay. So this is Marconics reagent is possible as reagent is possible here. Now next what happens here? You know very well how this hydration will take place here. Actually this can be a negative charge here. If I written this one like this, okay, so it is shifted here forms here CHC and here when H plus ions will be attached here. It forms actually this CH3. This will be an OH here. It will be an OH later. This will be an H here. Okay. Now see here. This is acid catalyzed reaction here. So anti Markovnikov's rule rearrangement is possible. Next one is Markovnikov's anti-addition. Second one demercuration. Markovnikov's rule are following anti-addition. Adding overall hydrogen and OH. Markovnikov's overall addition anti-addition we are doing here. Third one is zinc is there. Anti-addition. Zinc addition is there. Overall anti-addition is there here. Okay. Anti-addition directly we are not doing. Overall we are doing. Option C is the answer here. Okay. Next is the acid addition goes to the free carbocation rearrangement is possible. Oxymercuration demercuration goes through the cyclic mercury ion preventing rearrangement with an overall anti-addition H and OH. HBO is a concerted mechanism where the H and minus H and hydrogen and BH2 are at the same phase of alkene. Same phase they are saying. Same phase means this will be an hydrogen, this will be an BH2. Okay. Same phase will be there here, there also. Next one is the next one what they given Next one, isobutane and Cl2. Isobutane means, remember, CH3, single bond CH3, antioxidant CH3. For this one they are adding Cl. So you know there Cl here. One cell will become here, and later for this one what happens here? Elimination reaction take place. CH3 taken thrice, carbon OH, not OH. You can say chlorine here. Chlorine, they are adding chlorine, then they are adding alcoholic KOH. Elimination will take place. Then they will get a style structure. CH3, C double bond CH2. CH3. Okay. For this one, they are adding here again B2 6. Then also what happens? Then also get a primary only. So we'll get here CCH3, this CH3. Okay. Here CH2OH. I mean this is here you get, okay. CH2OH. So you can see 1, 2, 3. So 2 methyl, 1 mole, 2 methyl propane, 1 mole. Yeah, this is the answer. Okay. Next see here given here. Next one see here. Free radical substance, blah blah blah. They given. Next come to the next original. How JEE means is in 2021. They are saying this is a reactant they given there. They are adding air. They are talking about oxymercuration demercuration reaction. Now what they are saying here? CH3, CH2, CH double bond CH2. Now here what happens here? Here our Hg OCOCS will be attached here, and here is the least substituted carbon, right? So it will be first what will be added here. So later the protonation of hydrogen, mean removal of hydrogen will take place from the water, which will be attached here. So later this will be removed by the hydride ions by the our sodium borohydrate. Okay, this is later it will become H here. Okay, this is in one will go. So we can finally we'll get this like this. CH3, CH2, get here CHOH, and you'll get here CH3. Okay, so we'll get here CH3 second, CH3, CH2, OH, CH2. Okay, now we can just B right. Oxymercuration, demercuration. But on the butte one mean and result in the additional accretion of water according to the Markovnikov's rules and without any calculated element. OH attached the more substituted group OH, but is in water that attached, and later this deprotonation means minus 1 H plus ions it forms OH minus ions. It is attached to this carbon. Okay. Next. Next, see. And alkenes and reacting is alkene. They are saying alkene. Alkene is a reacting with an S2 plus S3O plus. They are saying gives tertiary alcohol. See, my question is, if you want to form a tertiary, how many carbon? 1 carbon, 2 carbon, 3 carbon, like this. Okay, na? And they are saying means that supposed to be like this. CH3, 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 and it will be an less simple or else what we can say. There must be an alkene, right? Alkene they are saying. Alkene means double bond rebellion. Now what I'm saying, I'll write three member double bond. 1, 2, double bond CH2. This is CH3. This is CH3. For this one, if you're adding this S2, then what happens? It will be shifted here, and later what happens? It will be an CH3. C positive and it forms a CH3. And proton, after getting the negative charge, one proton is attached here. Okay, so it will be an CH3. Here later what happens in S2 will be attached here. Later from S2 minus proton will be done, and then it will be formed. OH group will be attached here. Okay. So now testing here this one they are saying, and similarly this will be there. This what they are saying beauty at 6. This is then it will be an this will be an gives something like this. Here what will be attached here. Primary it gives. Anyway, our ORN will be gives primary only. Next one. In this process, Julian gives what they are saying correct sequential rearrangement required for the following. Cyclohexane. Cyclohexane means so एक दो तीन. This is hexene. Okay. Cyclohexene. Trans they are saying if you're adding KMnO4 or if you're adding osmium tetroxide, it gives like this compound OH OH. Okay. This is called both side. This is both sides same OH OH. This side is both we have hydrogen. This is called cis diol. Cis 1 2 diol they'll say. But what they want a trans. That time this will be follows trans. Okay. Later last question it is I think so. The major product from the following reaction is saying see here there are the tertiary carbon is there. Tertiary carbon if adding first it will be an shifted here it forms negative charge and in that same time it gets positive charge. So especially attached here it forms a CH3 single bond CH3 CH3 and it forms a CH positive charge it forms CH3 after addition of proton for this last carbon from here. Tertiary right that's why this 1 2 shift of this methyl group will be there. What is the result here? Sorry, it forms a CH, CH3. Okay, yes, it will be an CH3. This is the C. Here we'll get an air OH. This is our formula. CH2 taken twice, CH3 taken twice, C, and here we have next we have CH, CHOH. Okay, OH and yes, CH3 taken twice. Forms CH3 taken twice, COH. What will be attached here now? Written here. So let CH3 taken, COH. Here CH taken twice. Option B is the right answer. So finally we'll get here. This is summary. After iterations, no process followed. Mercuric oxymercuration and demercuration reaction. We are using this one. Sodium borohydride we are using follows and this is an anti-markovnikovsynhydration and this is an rearrangement is possible. This is not possible, not possible. Anti-addition and this is an zinc addition. Anti-addition and zinc non-stereo specific. Okay, so I also got idea about preparation of alcohol from the alkanes and alkenes by different method like hydration method and after by addition of sulfuric acid and borohydration method hydroboration method oxymercuration demercuration methods and all. So where we are using Markovnikov's rule and where we are not using Markovnikov, I mean where we are following anti-Markovnikov's rules and all we discussed I think so. So please subscribe share and comment in the comment section if you have any doubts. So thank you for watching. So anyhow I will upload the questions MCQs in the descriptions box along with solution. Please go through it and practice very well. Thank you.